Welcome to the Energy and Sustainability webinar series. This webinar is hosted by the U.S. Army Corps of Engineers headquarters from the Engineering and Construction Division. Today we are speaking on life cycle cost analysis, specifically an ECB that was published earlier this year, ECB 2015-7. Today's speakers are Mike Ternak and Arkie Fanning, and they will be answering our questions about the ECB. A couple things that I'll cover momentarily, if I get the right screen up, is that if you want CEUs or learning units for this webinar, you can go to the website shown on the screen. That's our Sustainability and Energy website. On the Mercy site, download the quiz. Quizzes are in groups of 5. If you answer the questions correctly, send your answers to s_ewebinar@usace.army.mil. And assuming you get the answers correct, we'll issue your credit. Be sure to include your AIA number if you wanted that registered with the AIA. With that, I'll bring up the presentation, and our first speaker today will be Mike Ternak. Mike?
Thanks, Eric. I'm Mike Ternak. I'm the Sustainable Engineering Program Manager for South Pacific Division, and I'm going to be co-presenting today with Arkie Fanning, who's the Chief of Cost Engineering for the Huntsville Center. Today's webinar, as Eric mentioned, is going to focus on some of the requirements in ECB 2015-7, and we're going to be presenting some of the minimum requirements for performing life cycle cost analysis for energy conservation alternatives during the design phase for our facilities, including buildings. And the way we're going to go through this webinar today is the first part of the webinar is going to focus on ECB 2015-7, which provides guidance on the LCCA for energy conservation and savings and the economics of energy efficiency alternatives during the design of our buildings. It's kind of going to go through, present some background on the legal and policy requirements to perform LCCA and why it's important. We'll have some slides on what LCCA products or deliverables are expected to be produced by design teams, team responsibilities for producing the LCCA documentation, and when the LCCA needs to be accomplished and finished in a typical Army MILCON project schedule. Then I'm going to turn it over to Arkie, who's going to go through some of the fundamental and basic information on performing the actual LCCA analysis itself, including some LCCA basics and critical LCCA factors and considerations. And then we should have time for some questions at the end of the webinar. So over the last couple years, Headquarter USACE has been working hard with the divisions and districts to develop a more formalized enterprise approach to identify the minimum technical criteria and processes for delivering high-performance sustainable buildings that meet all the legal and policy mandates for energy and sustainability requirements. So as this guidance is issued, they're following up with outreach to communicate, train, and implement this strategy, and these webinars are an example of some of this outreach. So LCCA is an important part of this enterprise approach. It takes into account all the costs of acquiring, owning, and disposing of a building or individual building systems and identifying the most economical alternatives. So one of the most important takeaways from today's webinar is that it's important to complete the LCCA early in the design phase, while there's still a chance to refine the design to ensure a reduction in life cycle costs. Well, why perform LCCA? First, because it's legally and policy mandated to us. Federal administrative laws require that buildings be designed based on the lowest life cycle cost or most life cycle cost effectiveness. And this is imposed through the Code of Federal Regulations on all federal agencies. Then if you drill down to DOD has separate LCCA guidance through a Tri-Services Memorandum of Agreement on criteria standards for LCA and economic analysis for MILCON design. Then if you go down to Army and Air Force, both the Army and Air Force Sustainable Design Development Policies require LCCA as an integral part of their process. The Army Sustainable Design Development Policy Update actually states, the Army will plan, design, build, and operate facilities to achieve the highest performing sustainable design that's life cycle cost effective within the program amount. LCCA is the tool to accomplish this. So performing LCCA for energy conservation alternatives helps ensure that we're designing and documenting energy and water conservation measures that demonstrate a strong return on investment and minimizes the total ownership cost of the facility. LCCA is the method or tool for assessing the total cost of facility ownership for designers and for the owner to make important decisions. It takes into account all costs of acquiring, owning, and disposing of a building or building system. LCCA is especially useful when you have a project alternative that are different project alternatives that fulfill the same basic performance objective or requirements, but have very different initial first costs and operating costs. The LCCA allows these different alternatives to be compared in order to select the one that maximizes the net savings. As an example, LCCA would help you determine whether the incorporation of a high-performance HVAC system or a building envelope glazing system is cost-effective or not over the life of the facility, especially when these different alternatives or different systems may have higher increased initial costs but result in dramatically reduced operating and maintenance costs. The LCCA will let you go through the analysis and determine which one is the most life cycle cost effective and makes the most sense from an economic perspective. To date, within USACE, there seems to be a lot of inconsistencies in the execution application of LCC in the design of buildings and USACE projects, and that's one of the reasons headquarters wanted to issue this ECB. The recent ECB directive and guidance is intended to improve compliance, standardization, and uniformity of these LCCA requirements in the design of USACE building projects. The ECB also is intended to improve the delivery of the design decision documentation and operational information to designers, building owners, and operators. The LCCA provides important information to influence and prioritize these design decision choices early in the design phase for decision makers, and to select building features that enhance facility performance and better quantify long-term investment decisions. So the purpose of the LCCA is to estimate the overall cost of project alternatives and select the design that ensures the facility provides the lowest overall cost of ownership consistent with quality, intended mission, purpose, and function. So who does LCCA in USACE? One of the intents of this new ECB is trying to increase the number and diversity of subject matter experts in performing LCCA. Typically, LCCA has been performed predominantly by mechanical engineers and cost engineers in USACE. However, it really is a tool that can be used by other disciplines as well. Ideally, LCCA should involve a fully integrated team. Ideally, a building level LCCA would have input and representative from all applicable disciplines, including the owner and operations staff, to identify all opportunities to improve building performance and increase savings potential. So it's part of our design process, so we're emphasizing increasing and building competency in this expertise. Some of the project team roles and responsibilities for performing LCCA would include project managers who are responsible for funding and putting together an integrated team. Design teams are responsible for employing integrated design principles to develop the energy and cost input data for implementation of any individual system or building level LCCA. Typically passive building energy features are done by architects or sometimes civils. Active systems, mechanicals and electrical engineers, and cost engineers typically would provide all the cost input data for LCCA. Owner, DPW or base civil engineer staff would share O&M practices and provide historical cost data if they have that for input into the operational costs. And overall, the design districts are responsible for assuring overall execution of the LCCA, including performing any quality assurance for AE designs. Now, the ECB does address design-build projects, and for design-build contracts, this ECB provides guidance to perform LCCA prior to finalizing the contract documents, or the RFP, and to try and get as much of the LCCA performed during development of the RFP as possible. The approach is that the preparer of the RFP has already completed an LCCA in the RFP development stage and include the selected alternatives as requirements in the RFP itself. Design-build contractors that would provide proposals that conform to the requirements of the RFP would then not be required to submit or perform an LCCA. The intent of this is to avoid tasking the design-build contractor with performing an LCCA after award that might significantly increase or decrease the scope and or cost of a lump sum firm fixed price design-build contract. So the design-build selection criteria would require that any contractor or proposing on an RFP that offer betterments or improvements to the requirements defined in the RFP, that they would have those betterments supported by an LCC in their proposal. Overall, the objective here is for design-build contracts is that to try and make the government more responsible for the LCCA and basically the design-build contractor everything else as much as possible. So what is required? So all project delivery teams must use the Building Lifecycle Cost Analysis BLCC program and follow the methodology that's identified in some Part A, Title 10 of the Code of Federal Regulations, Part 436, perform the LCCA for each building. The BLCC program incorporates factors developed by the National Institute of Standards and Technology, or NIST, complies with 10 CFR Part 436, and includes a MILCON analysis module. The link on this slide and the link provided in the ECB is the one that provides access to download the BLCC program for free, and there's guidance within when you download this how to use it. So the LCCA requirements are significant design activities that have to be performed for a building design to achieve high performance and sustainability facilities that comply with the Unified Facilities Criteria 1-200-02. Projects are required to meet the minimum energy and sustainability requirements described in the UFC. The UFC defines the minimum building requirements and is used as the project baseline for life cycle cost comparisons. For a MILCON project, we use a 40-year life cycle in the LCCA, or projected life of the facility that's different than 40 years. So the LCCA includes all costs of acquiring, owning, and disposing of a building or building system, including all O&M costs. The ECB requires that the LCCA analysis needs to be a separate part of and included in the design analysis or basis of design. For consistency, the LCCAs are to be conducted in accordance with the ECB guidance and applicable references. The final LCCA documentation must include a comprehensive summary that defines each alternative considered, including the assumptions and references provided for each parameter. The assumptions should be clear, documented, and of a level of detail that's sufficient that an independent third party or some other party could come in afterwards and duplicate the results of the LCCA based on the information or documentation that's provided in the LCCA documentation. LCCAs are to be completed using the same matrix of baseline information consistently across different alternatives to ensure a fair comparison is made between the alternatives. The LCCA is not the decision maker for alternatives. It provides unbiased information. If the most life cycle cost effective alternative is not selected, the LCCA documentation should explain the rationale or justification why another alternative was selected, which may include reasons for operational reasons, aesthetics, life safety, or perhaps budgetary reasons. Operational expenses for energy are based on consumption, current rates, and price projections. Because energy consumption, the building configuration and the building envelope are interdependent on each other, and energy costs are often assessed for the whole building, or for the building as a whole, rather than for individual building systems or components. However, the ECB is written around either a whole building LCCA or for individual kind of sequential systems analysis. For most MILCON projects, prior to the start of the design phase, the building site, orientation, and configuration have been established in the planning phase, the DD 1391, per the UFC. Early in the design phase, the building envelope, basic design features and components such as the roofs, walls, windows, fenestrations, daylighting need to be selected and analyzed for life cycle cost effectiveness. Selection of these passive, non-mechanical features helps minimize energy demands for the active systems. After these passive building envelope strategies are determined, the active mechanical systems such as the HVAC, plumbing, water heating systems, lighting systems, and control systems are selected, analyzed, designed, and integrated into the overall design. These active mechanical systems are the largest building energy consumers, so it's critical that design teams utilize LCCA to optimize selection of these systems. Now, when LCCA is required in the delivery schedule, the LCCAs must be initiated to validate the cost effectiveness of the highest energy efficient project within the program amount. During Code 3, the project scope and cost must be shown to support a cost effective project as described in the DD 1391. The final LCCA per the ECB is to be completed no later than Code 3, or typically what is considered to be the conceptual or 35% design. The LCC must validate a cost-effective project as part of the 3086 project review and be made a part of the design analysis and available for review. After that, any subsequent changes in project scope beyond the initial design that impact energy savings or project costs would just require an update to the LCCA that's already been completed. Well, at this point, that kind of covers the kind of procedural policy process steps through an LCA. At this point, I'm going to turn it over to Arkie Fanning, who's the Chief of Cost Engineering for the Huntsville Center, and who's going to go through some LCCA basics and
thanks, Mike.
Performing an LCC analysis.
The primary and the driving reason to do any life cycle is to prove out why you're choosing the alternative from a cost-effective standpoint. And it may not be that at the end of the day that's the alternative you select, but it's very important that you're able to say, well, we looked at that and didn't go with it because. That gives the decision maker the flexibility to define to anyone that needs the information why he needs extra funding above what the life cycle minimum would require. Some of the basics. It provides a method of providing a rationale for why you need the amount of capital investment you need, particularly if you need to increase the capital investment, and increasing capital investment would save you money in the future. You can show that. Often for different federal funding projects, requirements, you'll need to be able to show, here's what I did for life cycle and here's why it's most cost effective, in order to show that you are spending the taxpayer dollar wisely. What is very useful from a comparison between alternatives is if you use the standard methods, you get the right answer. The right answer may not be the correct answer at the end, but it is the right answer based on what you know at this point in time, and nobody can monkey with that one right answer. Now, you will do many other things to it if you're wise, such as sensitivity analysis, to show that, well, this right answer is only good for over this range of alternatives. But anyone doing this will get the same right answer. Calculate life cycle cost indicators. Again, that's like SIR, net present value, payback. There's several others. And that allows you to do rapid screening of projects sometimes. We don't see that much in the government, but in the private sector, there's often many ways for people to make money, and they use life cycle or some variant of it, such as SIR, to screen it, and they will take the highest SIRs or the highest net present value in order to determine where to best invest their money. The savings to investment ratio, we'll get more into that in the net present value. They will give you consistent answers. The best net present value will be your best SIR if you've done the math right. If you haven't done the math right, then it won't be. But these are different ways of ranking funding in some of our programs. And SIR, particularly in the ESIP program, is well defined. And but again, it does give you, if you do the net present value, rank them. You do the SIR and rank it, you will get the very same winners each time. Here's some of the data you're going to need. And before you ask me where do you get the data, we will go into that a little bit. But it's always very difficult to come up with very good data. The best place to find most of your O&M data is to go to whatever location you're doing the analysis for and try to find the old guy that's been there for 40 years in the DPM. He has stashes and stashes of information he can provide you. There are also some other places out there. Means has a pretty good O&M book, but there are other places you can find data. But again, in my 40 years of experience, I always like getting the old guy. He knows what's good, and he also knows why it's good. And sometimes that's very important too. You'll need an estimate of the annual energy cost. You'll need something for an estimate for the annual O&M cost, and always for the first cost. Typically what you're doing in the life cycle is you're taking first cost, you're determining whether or not you should make that incremental first cost for the savings that will result for energy or O&M. Those are the two big things. There's other things, repair and renewal also sometimes come into play, and other things, but typically it is, I'm paying more for this Cadillac than I would for a Chevrolet. That Cadillac is going to give me less cost for energy and less cost for operation and maintenance. Here's some sources, and again, I've already mentioned the DPW. That is a excellent place to get particularly O&M data, and it is wise not to tick those people off. So first thing I do typically when I go to a new base to try to gather data is go talk to to some of the old engineers there in the DPW and try to put myself on a good footing with them. If you can't get good data from them, you can go talk to a design engineer, and we're all design engineers. You know how easy we are to get along with. So, but it is a source. And then you can get all the cost if you can define the cost. You can get the cost from the cost engineer that's supporting the project. And again, he may get that from M2, he may get that from Means, may get it from Richardson's. There's several sources of information, but if you can define it to the point he needs it, he can give that data to you. If you have the key variables that we've told you about, you can develop a life cycle cost analysis that is defensible and repeatable, and both of those are important. Capital cost of new equipment, what's going to cost to install it. You're going to have for the maintenance, you're going to have the required maintenance and labor rates and compatibility, all of the sources. all the synergy that's possible out there needs to be known. If things operate more effectively with other things so that you've got some sort of chain going on, that needs to be recognized in your life cycle. Operations costs, energy and fuel use, labor for that. And the most important thing that you don't do and should do is sensitivity analysis. We see here at Huntsville Center we do a lot of life cycle, but we also review a lot of life cycles. And we'll go into later on all the things that we see as that we don't see or do see as a regular routine. But one of the things that really bothers me is you will get a life cycle in that says the net present value is $3 million for this alternative and $2.5 million for that alternative, and there won't be a sensitivity analysis. So what you have said is this is the right answer. You might not have known you said that, but that's what you said. And again, we don't know what the future holds. So what you should say is over a range of alternatives, and your cost drivers are defined by whatever's in your life cycle. So you should do a analysis that says, if my energy costs change by 5%, then I want to choose the other alternative. If my O&M changes by 4%, I want to change the other. I want to use the other alternative. That is just as important, in my opinion, as doing the primary, or what we call the base life cycle. So please watch out for that, and please do it when you are looking at your life cycle analyses. You would be surprised at how sensitive for some data that the life cycle is, because energy, you're going to be doing, usually energy costs go across 25, 35, 40 years. If you can save a little energy, it may be worth a lot of capital cost. And so, this is just another factor to take into consideration. But to me, it is a very important part of the analysis, and something that we do not do a good job of here in the Corps of Engineers of documenting. Some other things we don't see, and often not drivers, but sometimes are, the demolition cost we don't see often. People, I guess, assume that you're just going to abandon it in place, or that it's like most things with the government, it's going to last forever or stay there forever until they tear it down. But you typically need to make some sort of assumption on whether or not you're going to dispose of that and calculate the cost for that. It's difficult to do, but as long as you recognize that that will happen, and if your alternative hinges on that, to document that. The salvage value at the end of the useful life we often do not see. People just assume at the end of 40 years it's no good anymore, we're going to throw it away, whatever. That may not be the case, or whatever the life cycle is for electronic component or mechanical component, maybe 5 to 8 years. That may not always be the case. Again, you need to document your assumption as to why you're making whatever assumption you make in your analysis, and you should run a sensitivity parameter on it. The easy things are the discounting and escalation rates and the differential escalation rates. You can get that from OMB and from the NIST, and just do a search based on those parameters, and it will give you the latest guidance on that. We often see people misuse the NIST guidance because they don't understand it well. But if you do it right, all it's saying is that you have a base year, and from that year, the NIST guidance tells you years 1 through 5 from that is going to go up by some percentage or down for, say, electrical power, or for gasoline, or for kerosene, or whatever. Kerosene's a bad example, but number 2 fuel, number 6 fuel, you guys know the fuel indices that we use. And so, and it's by region, and it's just another way of making your life cycle more defensible, because price is driven not by just your first cost, but also by the area of the country you're in, by the, because of the area cost factor, and by the markets that's impacted at the time. And we all know it's going to be wrong, but at least it's defensible. You can say, well, I've taken the latest and greatest information that I have to do this with. And again, always do a sensitivity analysis on inflation, always do a sensitivity analysis on discount rates. Typically, people don't even understand discount rates, to be honest with you, but to be a good engineer, you should do those type of analyses. They think they understand inflation, but when you start throwing deflation at them, they really do get confused. And believe me, operating in a deflation arena is just bad news, because we're just, even after, I guess, 3 years now of really having short-term deflation, it's hard to explain to somebody. You're supposed to spend your money now rather than later. Typically money has more value now than later, and what it's saying is it's got more value later when you have a negative inflation rate. All right. Okay, this is just a kind of a alternative matrix I put together to tell you kind of where to go to get the information. Your best sources for O&M is always DPW. Your best sources for your energy is always go to your electrical engineer or mechanical engineer, get him to run some sort of analysis for you to give it to you. And the best source to get it done is go to your cost engineer. All of our cost engineers should know how to do basic life cycle cost, and if not, they can come to us and we'll be glad to give them a quick primer. It's not that difficult, and cost engineers that live in the cost world should know how to do it or be able to pick it up fairly easily. Some of the metrics that you'll see, and these are just the two main ones, but there are many others out there, and I think I got another chart in here that shows some more. But net present value is the one most important thing to understand. And I already mean that from just a life cycle for the government. In your own personal life, you should understand net present value. That should be a driver in your economic decisions you make as to whether to purchase a car, lease a car, whether or not you want to retire at 62, retire at 66, whatever, so when to take your Social Security. But net present value tells you the most likely impact of those decisions. And again, it's not always about maximizing your savings or minimizing your cost, but that is one factor, and that is one factor that you can tie down pretty well if you understand it. And net present value tells you if you've got 4 alternatives, this one is the best based on the best information I have before I do my sensitivity analysis. The savings to investment ratio is pretty simple. It's what's my life cycle savings and how much does it cost. If it's greater than 1, then it's a net present value that's greater than 0, therefore I want to pursue it. If you live in the ECB world, you understand that 1 is not sufficient. Typically 1.25 is a minimum in order to get funding, because this is not that precise a game. So the people that make selections as to what does and does not get funding want a little bit more assurance than a 1.0. But again, in the private sector, it's used often as a quick screening tool, and the higher serves will be the one that they want to concentrate on more to see whether or not they want to spend their money there. A little bit of net present value description. Negative net present value just means that it costs more than it's worth, therefore I don't want to pursue it. A positive means it's, it does give me money, therefore I do want to pursue it. Again, that's just on the cost side. There are many other things that go into the analysis to make the final determination as to which alternative is selected. So again, is you sum all the discounted savings, sum all the discounted cost, look at it, go if it's greater than 1, no go if it's less than 1. ECB has a pretty good form you can use, and you can look at that and take it apart and develop your own SIR if you care to for other circumstances. But it is pretty simple. Once you understand the time value of money, which is all discounting is, then it is putting everything at one point in time and making your decision based on that one point in time for the cost or the savings. Some other things you'll see. A benefit cost ratio is something that they do a lot on the civil works side, and coming up with the benefits and the cost are not as simple as what we experience in the military world, because often well, anyway, they have it's more difficult. Not because the math is harder, but because you've got to take into account public good often, where we don't have to in doing our numbers. But again, the concept is simple. My benefits have to be greater than my cost. So if you divide benefit by cost and it's greater than 1, it's something I want to do. Simple payback will get you in trouble. I don't ever use it myself, but a lot of people do. Then it's kind of one of those rule of 72 things where you kind of look at it and say, well, it looks pretty good, therefore I'm going to go with it. And a lot of people use it as a screening tool, and for that it's probably okay. But what it says is, when do I get my money back? But it doesn't discount the dollars. So if you're talking a short time frame, a year or two, it's not going to be much difference. But if you're talking 7 or 8 years, there might be a huge difference between alternatives. So I use simple payback very rarely, but a lot of people do use it. And again, it's simple. It's when do I get my money back based on non-discounted dollars. So it's how much does it cost me, how much is it saving me, when is that profitable for me. The discounted payback, which is similar, but actually takes into account the discounted rate of the money and of the the cost and of the benefits. Well, that is a very useful tool, and it will give you a precise number based on whatever information you put into it, and it will give you the same answer as the SIR and the net present value. And if it doesn't, then you've done the math wrong somehow, or you use different assumptions somehow. The way the math works, all of these should be equivalent. So if you do a net present value that shows positive, then the SIR is going to be greater than 1, and your discounted payback will be whatever it is, but it will be in those terms, which is the discounted rates. Here are some common mistakes. The one that drives me nuts the most often is the sensitivity analysis. Of course, we do this a lot here at Huntsville Center, so I'm more in, I guess anyway, we do it a lot here. So it's the first thing I know to do when I get through doing my problem analysis. I got to show just how robust or how good it is. A lot of your decision makers won't see many life cycles. Therefore, if you tell them that alternative A is better because it's 3.2 million versus 2.8 million or whatever, they'll say, hey, that's good, go with it. But what you should have told them is it's good for this given set of circumstances, but if circumstances change, and you might want a different decision. And then they may know something that says, hey, this could happen, that could happen, or I don't like that assumption or whatever, and would change their decision. So as a decision maker, as a engineer, you owe it to the decision maker to give him the best decision you can. And sensitivity analysis performs that within, the limits, of course, of the mathematics. Lack of common metrics, we'll often see discounted payback and payback mixed up, and we'll often see SIRs done incorrect. Again, we do it for a living, so we were easy to find that one. But make sure you use the same metrics across all your alternatives, and make sure you do the math right. Misuse of common metrics. I've seen the actual inversion of decisions based on, well, it's cost versus benefit type deal. Choose the cost, and you should have chosen the benefit, and make your recommendation based on that. Data entry errors, probably the biggest one, and we're all guilty of this, including me. The use of outdated data. We do the best we can to come up with good data. Good data is hard data to find. But if you do get data that is 2 years old, make sure that at a minimum you apply some sort of escalation to it based on some logic. Typically the general inflation rate will be okay, but for some esoteric things it's not okay, and you need to know enough about your life cycle to determine, well, I really need to use some special index for that. So but of course market data is the best data you can get. It's also expensive, it's hard to come by, and it takes time. So everything you do is an amalgam of how much have I got to spend on this, what's the importance of the decision, how much time have I got to do it, and am I going to get cussed out a whole lot if I'm wrong. So Okay, incorrect data, a discount rate. If you use discount rate in the A94, you will not be wrong, but you'll be surprised how many people find something on the web that says, oh, discount rate should be 10%, therefore I'm going to use it. Don't do that. Go to the A94, get the right discount rate, whether it's and you got to know if you want to use a current or constant dollar analysis too, but it's pretty easy to determine which one is correct for your particular application. And the incorrect assumptions is a big one. You all professional engineers, I'm sure you're not going to have any incorrect assumptions. So, okay, some final considerations. Life cycle is not the decision maker. It is one more input in the design or in the decision, whatever this happens to be. It should be unbiased, and it should not be used to drive a pre-selected alternative, which it often is. Okay, I probably shouldn't say that out loud, but it can be, I should say. It should be unbiased, and it's your best estimate of what something will cost, with everybody understanding it's not correct, but it's the most correct you can make it at this point in time. Often we will select non-cost-effective life cycle for other reasons. There are many, and it shows some here. Often synergy with other things is in there, and that's not shown here, but often that is in there. And the purpose of life cycle is to show you have done your best to make sure that you have selected the correct alternative, why you selected it, and why you are spending taxpayer dollars appropriately for the decision maker. All right, I'm through preaching, so if anybody has any questions, I'm going to turn it back over to Eric, and he can have at it.
Okay, thank you, both Arkie and Mike. This is Eric Mucklow. I've opened up a panel on the right-hand side. At the bottom of it, there's a text entry block where you can type in your questions. You can either direct them toward Mike or Arkie, or leave it blank and I'll just read them. Because I'll read the questions aloud, consolidating any redundancies, and read them for the sake of the recording. A couple things I wanted to point out in the interim. In the web links block, we have a link to the ECB page on the whole building design guide, as well as a link to our Mercy site, the sustainability and energy site, as well as a link that was on a previous slide to the BLCC on, I believe that's a DOE website, as well as a link to our past webinar videos on our private YouTube channel. In the file share area, we have a link you can download this presentation, PDF, PowerPoint rather, and a PDF of the ECB if you want to reference that as well. I'll let people have a chance to download those things as we go through the questions, and I'll leave the screen up a little bit after the presentation. Okay, so first question is the requirement least life cycle cost effective or life cycle cost effective? I think they want a clarification.
I'll go ahead and take that one, Eric. For Army projects, the answer is, because they throw the programmed amount into the answer for that question. So the Army's criteria is to achieve the highest performing life cycle cost effective design that's within the program amount.
Okay. Is there a number of alternatives that are required to be looked at? Does the ECP dictate?
That, I believe generically they're looking for 3 alternatives if it's possible when you're comparing alternatives or individual building systems, if possible, if that many exist.
Okay. And also, if the given those previous 2 answers, how are we going to meet net zero requirements if it's not necessarily life cycle cost effective?
Well, that's going to be a challenge, of course. at some point, either the costs of the technologies that help us achieve net zero are going to have to come down, or the program amounts are going to have to go up if net zero is, the ultimate goal.
Right, and sometimes I know we refer to making our buildings net zero ready, which is getting them as efficient to a point where any dollar added for efficiency would cost, or any more efficiency in energy would be at a cost, for that infrastructure in the facility would be at a cost that it would be equal to or greater than the cost of energy produced by an alternative energy system. Because obviously to net zero, since it's not likely that we'll ever be able to use no energy, at some point we'll have to integrate a renewable energy system or alternative energy system. Okay, let's see here. We have one. How does LCCA apply to Army-owned facilities for civil works projects, renovations and new constructions? Are the requirements the same as for Milcon?
Well, that's a good question. For the civil works side of the house has issued a policy, a sustainable policy for internally owned infrastructure for our civil works operations side of the house. And basically for any new construction or major renovation, that civil works policy requires compliance with the UFC. So, and the UFC, of course, references life cycle cost analysis. So, it's basically the same as Milcon projects. The only difference I see in that civil works operation policy is they do not require LEED silver like we still have a requirement for in Army and Air Force Milcon. So any new construction, you don't see very much new construction in civil works operations. It is required to comply with the UFC 1-200-02. Now there is no guidance for this for the civil works side of the house that's funded with non-federal sponsors for the general investigations or construction general appropriations. There's no policy guidance on that one way or the other.
Okay, and as far as performing LCCAs, what is the average cost or time to perform a proper LCCA in your experience?
I'll answer that one. I've done 1,000 of them. The answer is and this is a terrible answer, but it's true. It depends. Sometimes it's as quick as 3 or 4 hours. If you got the data information, it's just math. You can go in, take your software tool, go in, plug it in, and you get your answer out. And then if you're smart and you got your sensitivity parameters already set up, blah, blah, blah. So it's 4 to 8 hours for something simple. I've also spent weeks on them because they were so complex with many different factors. We typically ask for 40 hours when we're doing what we call a building or a major system analysis. And if we're doing some subset of that, we go down from there. But that's a bad answer, but it is a true answer. It's highly dependent upon the situation.
Okay. Are there any recognized industry sources for maintenance costs?
Yes, this is Arkie Fanning again. We use the Means O&M manual. It's easily found online. Richardson also has some. We find them useful for most things we do.
Okay. Now, if the LCCA is needed up front for design build request for proposals, does the RFP become totally prescriptive for the envelope HVAC systems and lighting, etc., or does there remain some latitude for the design build KTR?
I'll take that one. Yeah, I think we're very early in this new requirement to try and get the LCCA performed in the RFP or put those prescriptive requirements on the contractor. And so I've been in some discussions with headquarters on this to see if we still have maybe a conflict between what this ECB says and what some language that's currently in the say the Army RFP wizard for design build contracts, for example, where they still reference the design build contractor to do LCCA. So I think the answer is it's probably prescriptive when we say it's prescriptive, and there may still be some features that are going to be identified for the contractor to have to do some level of LCCA, although the intent is to try and move this more and more towards the government taking responsibility for that, because we're trying to make sure that the design build contractor doesn't have like a wide range of uncertainty in his proposed cost that isn't determined until the LCCA is completed, which will be after award. So trying to minimize things that would significantly affect the cost of the design build contract after award, or the scope of the design build contract after award.
Okay, and there's a question about if there are cost libraries, in quotes, available that could be reused with certain variables changed repeatedly, like EFIS system costs or IMP costs for building envelopes.
This is Arkie Fanning. If there is one, please let me know, because we're not aware of them.
Okay, and somebody wrote in to follow up with the comment about the time and cost for an LCCA that it sounded like it didn't include the a cost for energy modeling. That's kind of a different thing.
Yeah, it did not. That was cost engineering time only. I'm sorry, I should have been more specific with that. Yeah, I would not be a good one to ask what it would cost to do an energy model, because we always go to ask our design engineers what that is, and then they do it. We don't ask them how much time they get the project manager for them.
And somebody asked, where can we learn how to do a sensitivity analysis?
This is Arkie Fanning again, there are many life cycle books out there. All of them tell you how to do a sensitivity analysis. You can go to Amazon if you want to buy one. If you just want to go online, NASA has a good one. And I've forgotten. There's several others out there. But if you do a web search for life cycle cost sensitivity analysis methods, I'm sure you will get something that's free. If you want to pay for something, you can go to Amazon. And like I said, last time I checked, there's like half a dozen life cycle books out there, and they all include how to do a sensitivity analysis.
Okay.
But it's not that hard. Think about it. It is the things that drive your analysis on the cost side or the benefit side, whichever one it is. You want to pressure those things to determine when your decision would change. So when your net present value goes from positive to negative, at that point you capture that data. Let's say that your inflation rate is 3%, you make it 4%, and then all of a sudden you get a negative life cycle. You say, okay, my analysis is good from 0% to 4%.
Okay. Now, will this? Can you give us any information, or can you tell us about any prospect courses that are available?
As far as I know, there is no life cycle prospect course. We have pitched it a couple of times, and so far come up empty. Let me to get back to the book. The core. Can you send out an email to all participants after? I may have something that will suit their purpose that the USACE's already paid for. I just need to get permission from from the person that paid for it to release it, because it's not really my work. But no, we would be more than happy to put on a prospect course. Trouble is, we've not found enough interest in order to do so in our past surveys.
Okay. Well, maybe the ECB will generate the interest. And there's one more about the ECB itself. In paragraph 4, the scope describes the applicability to projects with a construction cost of greater than 2.5 million. What is the intent for smaller projects?
Well, basically for smaller projects, this ECB would not apply. So it's my understanding that you would not have to do this level of detailed LCCA for projects that are under 5,000 gross square feet or under $2.5 million PA, as far as the life cycle cost analysis goes.
I suppose there's a certain point where you spend more time and effort than you would save on something that's really, really small, but and also just tracking all that. But it doesn't mean you can't do one. It just means you're not required to.
True.
So yeah. Okay. Well, we are almost at the hour, and so I don't see any more questions coming in. I will leave this website, our website here, webinar page up a while, so that people can remain on if they want to and follow those links or download those files. And thank you again, Mike and Arkie, for being here today. And if anybody, again, I'll come back to put the website up for the quiz and for the SE webinar email address, so that people can submit to get their CEUs if they're interested in that, if they have attended, and answer the questions on not just this, but for other webinars as we do them.